Okay, this is a chapter 20 video, and it's dealing with acids and bases. This is going to be section 20.1. So 20.1 is dealing mainly with properties of acids and bases and naming. The first part's a review of middle school, and the second part is a review of earlier this year. So I'll quickly run through these. Properties of acids and bases, we're just going to write next to it which is an acidic property and which is a basic property. When you think of acid, I want you to think of lemon juice. And when you think of a base, I want you to think of soap. And that'll get you through most of your properties. And so a bitter taste is going to be like soap, so that's going to be for a base. A sour taste is like lemon, that's going to be for an acid. Changes indicator color, and we'll talk later about what an indicator is, but both of them will change the color of an indicator. Reacts with metals to form a gas would be an acid. And this is actually a review of your single replacement reaction, so I'll just give you one real quick. You'll have hydrochloric acid and a metal. It has to be a metal from the reactivity series for single replacement. So I'm going to write that down. It's review of single replacement. And so you're going to pick a metal higher on the activity series. For instance, calcium would work. And what happens is calcium will replace the H, pairing up with the chlorine. Since calcium's +2 and chlorine's -1, the formula that will form is CaCl2. And hydrogen will go home alone. However, hydrogen always travels in pairs because he's one of the 7 diatomic molecules. So they'll go home like that. Because it feels wrong to leave it unbalanced, you're going to give it a quick 2 over there. This is how acids react. This is actually a review, but we don't remember. It's been a very long time. Feels slippery, that's going to be like soap or a base. An electrolyte means it conducts electricity. Which also means it breaks up in water. Which is another way of saying it's soluble. So those are all saying the same thing. So actually it's going to be both. Acids and bases break up in water and do that. Scooching on, naming acids, and this is all just a review. So if it begins with hydro and ends with ic acid, it means the base used to be an ide ending. And since the formula for chloride is Cl-1, it will take one acidic H to balance the charge of the -1 charge. So the formula when you're done, HCl. The second one is sulfuric acid. This is the second type. And if it ends with ic acid but does not have the hydro in front, then you know that it used to be a sulfate ending, and since you review your polyatomic ions frequently, you know that that's just SO4-2 or SO4-2-. But this one will take 2 H's to undo the charge of the polyatomic, forming this acid, H2SO4. Nitrous acid, us acid means it used to be ite. And once again, you review these frequently. So nitrite is NO2-1. You'll need 1 H to undo the charge of the -1. So you'll put 1 H in front and you get HNO2. And that's your final answer for that acid. Then there's a couple you're just going to have to memorize. So ammonium, you've already memorized as a polyatomic. I'm just telling you it's an acid. Learn it. Ethanoic acid has this formula. But you probably know it from in the fall, we called it acetic acid, which is an acetate with H's to balance out the charge. So since acetate is -1, it will take one H to balance the charge. If you count, there's 2 carbons, 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens. They're the same compound. They have different names because different chemists use different naming systems. If you were in your kitchen or you were a chef, you would call it vinegar. The molecules don't care what you call it, but I need you already know this name, but I need you to know that name as well. Next, naming bases a review. The most common base is just a simple hydroxide. Just a hydroxide hanging out. You can have the hydroxides with different metals. Calcium is the alkali earth metal, so he's +2. And if you take a +2 calcium and combine it with the hydroxide, you're going to get a CaOH2. The charge on this iron is +3 because the Roman numeral is 3. Good review of nomenclature. Hydroxide still -1, so you'd put those together in such a way that the charges would cancel. So it will take 1 iron and 3 hydroxides to cancel. And then for ammonia, you're just going to remember, you know what? Ammonia is always a base. Just like ammonium is always an acid. Always. Let me give you a good equation just to kind of have in life. NH3 plus an H will form NH4. Or I could have put NH4 on the left and the NH3 and the hydrogen ion on the right. It doesn't matter. It's a double-sided arrow. Post chapter 19, we can use double-sided arrows. And that's a quick review of 20.1.